Hello everyone, and welcome to your video which is going to talk about the angle bisector theorem. So first let's put in our notes what it says. It says in any triangle, an angle bisector divides the opposite side in the same ratio as the other two sides. Let's take a look at an example so you can see what I'm talking about. So let's draw ourselves a nice triangle, and I'm not going to draw an equilateral because I don't want you to assume that it's always going to look as nice and neat as an equilateral triangle. But I'm going to draw this little triangle, and I'm going to cut this angle up here. I'm going to bisect it, which means I'm going to cut it exactly in half. And just so you know, don't think that that means that that's going to cut this whole thing in half, because it won't. If I cut this exactly in half, I'm going to wind up about here. If I were to really cut this segment in half, like if this were going to be the midpoint, I'd have to be over here a little bit, right? In order to make those two sides, this side and this side, the same. So this is not the midpoint of this side. Here, I'll label these. This point right here, which we will call N for not the midpoint, it is not the midpoint. It is bisecting that angle, however. Okay, so let's label our sides. We'll call this side little x, and we'll call this side little y, and we'll call this side little m, and we'll call this one side little n. And what the angle bisector theorem tells us is that x divided by y is going to give us the same number as m divided by n. So x divided by y will give us the same number as m divided by n. Let's do an example so that you can see what I'm talking about. Okay, so now we're done with our notes. I'll draw you another triangle, which you cannot quite see. There we go, okay. And I'm going to bisect that right there. And I'm going to tell you that this side is 15, and I'm going to tell you that this side is 22. And then I'm going to tell you that this side is, oh, what should we say? We'll say 10, okay? All right, so let's calculate and see if we can determine what this side is. So what the angle bisector theorem says is that I can take my two side edges, 15 over 22, and that is going to equal these two edges, 10 over x. Notice that since I put 15 on top, that's this triangle, I have to put the 10 on top over here because I still want to be dealing with this triangle. So in other words, this is my left triangle and my left triangle divided by my right triangle and my right triangle. Right? Because I have to have things lined up kind of properly. All right, let's see if we can do this math. So this is going to be 15x, because we're going to cross multiply, equals 22 times 10, which is 220. I divide both sides by 15, and I really hope I get a nice normal number. Let's see what I get. I get 220 divided by 15 equals, of course, not a nice number. I get 14 2/3, right? You get 14.666667. But that is our answer. So that is the side length of this side right here. And we know that because as long as these two angles are bisected, that is cut exactly in half, then we can do this kind of math. Let's do another one. I'll make my triangle look a little bit different this time. I'll make my triangle look like this. okay? And I am going to bisect this angle right here. I could bisect a different angle if I wanted to, but I think this is going to be fun. I'm going to bisect that angle right there. So that is completely cut into half. And then I'm going to give some numbers here. I'm going to say that this is 20. I'm going to say that this is 60. And I'm going to say that this right here is, let's say 40. Okay? All right. So we want to know what x is. Can we figure that out? Well, of course we can figure that out. So I'm going to say, okay, so 20 divided by 60, that's my left triangle divided by my right triangle, is going to equal my left base divided by my right base. Left, right, okay? All right, let's do this math. So this is 20 times 40, which is, I think, 800, but let me just check. 20 times 40 is, yes, it's 800. 800 equals 60x. Divide both sides by 60. And I get x equals 13 1/3. Wow, I really seem to be stuck on these 1/3, right? So x is 13 1/3. What I'd like to point out to you that might not be obvious is that I could set up my proportion differently. So let's say that I did 20, my left side, divided by x, which is my left base, and I set that equal to my right side divided by my right base. Is that okay? Well, yeah, because I'm still going to get 800 equals 60x, which is exactly what I got before. So x is still going to equal 13 1/3. Let's see, can we think of another way to set it up? What if we set it up like this? What if we set it up like, let me see. Let's set up x over 40. That's my left base over my right base equals 20 over 60. That's my left side divided by my right side. That gives us 60x equals 800. So x is again 13 1/3. My point is that your proportion could be set up a number of different ways, but it's always going to bring you back to the same value for x if you set your proportion up correctly. All right, so that is the angle bisector theorem. If we cut that angle in half, then the remaining sides are in proportion to each other. I hope that makes sense.